fall in, you never come out, stretching you from head to toe. Death by black hole.
Black holes were suggested by John Michael and Perry Laplace. It was known that the escape velocity for any object depends on only its mass and size. They believed that there could be any object so strong that not even light could escape. John Wheeler came up with the name black holes due to the black meaning that nothing can escape, and that is the way black holes were termed.
So we chose the topic black holes because they're very hard to understand. Like, a lot of people think they're a myth, a lot of people say they're not, but and also I didn't understand like how that even works. Like, I know it's because the sun died out, that's what I knew before this class, but I just really didn't understand the concept of it that well. But now that we do know it, we know that they're not a myth, they're actually real, and they're still a little hard to understand, but we know that they, I guess, suck up, like gravity pulls them together, and so that's what we've learned so far.
So a black hole is one of the possibilities for the final stages of a star's life, but due to the gravitational nature of black holes, it will theoretically exist forever. What does this mean for the future of the universe? Will all matter in the universe eventually form together in one large black hole?
So for the sake of analogy, let's compress all of space-time into a flat two-dimensional object such as a bed sheet. So when we place a massive object on this sheet, per se, it creates an indentation. So let's pretend that we placed a metal marble in the middle of this sheet. Now, since we have this indentation, any object that we flick at it, say another marble, is going to curve its trajectory until it actually curves into the marble itself. So when this happens, let's pretend that a certain area around this initial marble that's causing the large indentation is the event horizon. And so the event horizon essentially means the point at which there is no return. So it doesn't matter how much energy you expend, you're not going to escape the gravitational pull, or in this case, the bend of the sheet. So when it comes to black holes, there comes a point when the energy needed to, escape the black hole exceeds the speed of light. And if you're at all familiar with physics, faster than the speed of light is equal to no. So, also in reality, instead of just a slight indentation, a black hole is more like a bottomless chasm into the abyss. And so, it's kind of a weakness in the analogy, but hey, it's an analogy.
The instructor could have taken longer to expand on the concept. Adding more examples that refer to theory rather than an emphasis on mathematics could be easier for students not so well versed in math to understand the topic and find it more enjoyable.